Hey everyone, and welcome to The Explainer. Today, we are unlocking the absolute bedrock of software development. I mean, if you've ever wondered how programs actually make decisions on their own, well, you are in exactly the right place. We're diving deep into Python fundamentals, specifically zooming in on control statements and loops. We'll be drawing our insights today from the foundational teachings of Mr. Darai SK. This explainer is really all about giving you the structural tools you need to write smart, highly efficient code. Let's get into it.
So here's our agenda for today. We're covering controlling program flow, making decisions in Python, the power of loops, and modifying loop behavior before wrapping up with a quick summary and next steps.
All right, let's kick things off with Section 1, Controlling Program Flow. Now, I want you to think about this for a second. How do we make our code actually, think, rather than just blindly running from the top of the file to the bottom, line by line, without any awareness of what's going on around it? Well, that brings us to our very first core concept, control statements. You can really think of these as the absolute brain of your program, because without them, a computer reads code like a super stubborn recipe. It just does step 1, then step 2, then step 3, no matter what happens in the kitchen. Control statements free your code from that rigid execution. They allow the program to dynamically decide its flow based on specific conditions that you set up.
Moving right along to Section 2, Making Decisions in Python.
So now that we know we need a brain for our code, how exactly do we build it? Well, Python gives us three main decision-making tools: the if statement, the if-else statement, and the if-LFL statement. Notice how they kind of progressively level up in complexity? We start with a simple single check. Then we move up to an either-or scenario, and finally, we scale all the way up to handle multiple possible paths and outcomes.
And this brilliantly illustrates the absolute simplest decision of them all. With a standard if statement, like checking if age is greater than or equal to 18, a single true condition triggers an action. Using this voting age example from our source, it's pretty clear how it works. If the person's age is 18 or older, the program prints the message. But if they're 17, literally nothing happens. The program just shrugs and moves on. It's a simple one-way gate.
Now let's see how this builds into something a bit more robust with an if-else statement. Think of this as a literal fork in the road, where the program has to choose one of two distinct blocks depending on the condition. In one scenario, if the student's marks are 50 or higher, boom, the program prints pass. But in the alternative scenario, if that condition just isn't met, the otherwise kicks in, and it prints fail. The else basically ensures that no matter what, a definitive action is taken.
All right, let's switch gears into Section 3, the power of loops.
So we're shifting from the brain of the code to the muscle. Because if control statements help our program make smart decisions, loops are what allow it to do the heavy lifting. Loops let us execute a block of code repeatedly without writing the exact same code multiple times. And honestly, this is absolutely vital. Imagine you need to send an email to 10,000 subscribers. There is no way you're typing the send email command 10,000 individual times, right? Loops are your essential time savers, keeping you from tediously repeating yourself and keeping your scripts nice and clean.
Python mainly gives us two distinct types of loops to handle this repetition. First, we have the for loop, which is used when the number of iterations is known in advance, like when you know you want to process exactly 10 items. Second, we've got the while loop. This one's a bit different. It doesn't have a set number of runs. Instead, it just continuously executes as long as a specific condition remains true.
Take this for loop, for example. For I in range 1 to 6, print I. Now, because the range function in Python goes up to but doesn't actually include that final number, a classic Python quirk, right? This simple loop perfectly outputs the numbers 1, 2, 3, 4, and 5. We knew we wanted exactly 5 iterations, and it handled it flawlessly.
Now, check out how a while loop tackles that exact same task. While count is less than or equal to 5, print count. And then, and this is absolutely crucial, we have count plus equals 1. It achieves the exact same output of 1 through 5. But do you see the structural difference there? It completely relies on that counting condition. We have to manually add 1 to the count during each pass because that condition must eventually break. Actually, think about it. If we didn't add 1, the count would always stay at 1. It would always be less than 5, and the loop would literally run forever.
And that danger of an infinite loop segues perfectly into Section 4, Modifying Loop Behavior. We've built the muscle, but now we need to give you, the developer, the steering wheel and the brakes. Python provides this awesome matrix of control with 3 precision tools to manage your loops. First up is break, which stops the loop immediately. That's your emergency brake. Second is continue, which skips the current iteration and jumps straight to the next one. And third is pass,
which is this fascinating little statement that literally does nothing. It simply serves as a structural placeholder for code you just haven't written yet.
Let's actually demonstrate the sheer power of that break statement using the example from our source. Imagine we're running that same loop meant to count to 5, but inside it we nest a control statement. If I equals 3, break. So what happens? Well, the loop starts, it prints 1, it prints 2, but the absolute second that I equals 3, boom, the break statement is triggered. The loop abruptly stops. The output is just 1 and 2. It's an incredibly handy way to tell your program to stop searching the moment it finds exactly what it needs.
Which brings us to our final section, Section 5, Summary and Next Steps. We have covered a lot of ground today, transitioning from basic logic to powerful automation. To quickly recap your vital new toolkit, you now know how to control the flow of your applications with if-else, and if-else-else logic. You know how to dramatically reduce your workload and repeat tasks using for and while loops. And you know how to safely direct that loop behavior using break, continue, and pass. The crucial takeaway here is that these aren't just arbitrary syntax rules. These concepts form the absolute foundation for solving complex programming problems efficiently. Which leaves us with this final, exciting question to ponder. With decisions and loops now fully mastered, what will you build next? You possess the brain and the muscle of Python now. The possibilities are truly endless. I want to echo Mr. Durai SK's wonderful sign-off and challenge you to apply these new superpowers in your very next coding project. Happy coding! Thanks so much for watching this explainer, and we will catch you next time.